Hi, this is Mr. Krebs. In this video, I'll be reviewing exponent properties and solving exponential equations. Exponent properties, now, I'm going to do these in my specific way. There are many different orders in which you could do a lot of these operations, so your process may be a little different than mine. As long as you're following one of the rules that we have, it should be correct. So let's get started. I'm going to start with the exponents that are outside the parentheses, and I essentially have to distribute these to each of the terms that's within the parentheses, because inside we only have multiplication. The important thing to note is any term that does not appear to have an exponent actually has an exponent of a 1. So 3 is not just 3, it's really 3 to the first. And to avoid silly mistakes, I always add exponents then to anything that doesn't seem like it has one. So in here, I have 3 to the first, and I have squared. I multiply the 1 and the 2 to get 3 to the second. Multiply negative 5 and 2 to get x to the negative 10th. Then multiply 2 and 2 to get y to the 4th. The other side, I have multiplied, see, 1 times 3 is 3, so I get 2 to the third, x to the third, and y to the third. Alright, let's see, go through here, let's clean things up. 3 squared is 9. X to the negative 10th and x cubed, since I'm multiplying these now and they have the same base, I can add their exponents. So negative 10 plus 3 is 7. And then y to the 4th and y to the 3rd, they have the same base, so I can add their exponents to get y to the 7th. Last thing I have in here is the 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. Two more final things to do before this one is simplified. 9 and 8 are constants that I can multiply. So 9 times 8 is 72. X to the negative 7th, I don't want any negative exponents, and there's a property that says, well, if you want that exponent to be positive, move it to the denominator. So that drops to the bottom, and then I have my y to the 7th. I know that's simplified because I do not have any terms of the same base in more than one place. All my exponents are positive, and I do not have a constant that can be simplified. For the second problem here, same kind of first step here is I'm going to distribute, in effect, this 2 to each of these exponents. So I get the 4 an exponent of 1, the 2 an exponent of 1, and x an exponent of 1. So I get 4 squared, x to the 4th, y to the negative 6th. On bottom, I get 2 squared, x squared, y to the 10th. Okay. See, 4 squared exponents are first order operations. I cannot cancel these because I don't divide until I do the exponents. So 4 squared is 16. Let's see, x to the 4th. Now I have a property here. If I see these guys, I can subtract the exponents. So x to the 4th minus, or 4 minus 2 is x squared. And now here, I could subtract, but if I do negative 6 minus 10, I can get negative 16. I'm going to try to avoid that. So instead of subtracting here, I'm going to try and get rid of the negative 1, by moving it to the denominator. So let's see, this x squared is gone, 2 squared is 4. I have that y to the 10th. Then I'm moving this y to the negative 6 to the bottom to make the exponent positive. At this point, I see 16 over 4, and that simplifies to 4 over 1, or just 4. I have x squared on top, which isn't going anywhere. And then y to the 10th and y to the 6th. I'm multiplying two things with the same base, so I can add the exponents to get y to the 16th. Okay. Moving on to solving exponential equations. The key for these guys is to get both the bases to be exactly the same. In this case, I have 3 and 27. 3 I'm not going to change because it's fairly simple as it is already. But 27 I could write as 3 cubed. 3 times 3 is 9, times 3 is 27, and it's still being raised to the x minus 1. At this point, I can multiply these, because a power to a power is the product of the powers. So I get 3, so let's see, 3 times x is 3x, and then 3 times minus 1 is minus 3. Right, it's a very common mistake to not multiply this by the second term. At this point, if the bases are the same and the two different sides have the same value, it must be the case that the exponents also have the same value. So I set these guys equal to each other. Now to solve, subtract x from both sides, add 3. 2x is equal to 7, and divide by 2. Say x is equal to 7 halves. Alright, on the right side, 5 is already a relatively simple base, so I'm not going to mess around with it. But 125 I'd like to rewrite with a base of 5. And that would give me 5 to the third. 5 times 5 is 25. 25 times 5 is 125. Set the exponents equal. 4x plus 7 is equal to 3. Subtract 7 to get 4x is equal to a negative 4. And divide by 4 to get x equals negative